Hi students, welcome to today's class. Today I am going to discuss very few fundamental concepts regarding the chapter Hyperbola. So which are very useful for both your board examinations and your competitive examinations like JEE mains examinations. Okay, so without wasting your valuable time, so let us start our class. Now in the previous class I have we discussed about the equation of the standard form of the hyperbola and a few concepts given a point how the point whether how it lies between outside or inside or on the parabola. Now I am going to explain now one type of parabola, that is conjugate hyperbola. Okay, so one type of hyperbola I am going to say, that is called conjugate hyperbola. What is this conjugate hyperbola? So let us see the definition of the conjugate hyperbola. So let us see so this is the equation, this is x-axis, and let us take this y-axis, and it is origin. Let us take C as the center of the hyperbola. Okay, so here A dash is called transverse axis, and B dash is called the conjugate axis. A dash is called transverse axis, this is called transverse axis, and B dash is called conjugate axis. And the equation of the hyperbola is x square by a square minus y square by b square is equal to 1. The equation of the hyperbola is x square by a square minus y square by b square is equal to 1, where b square is equal to a square into e square minus 1. Now, conjugate hyperbola is a hyperbola whose transverse axis is the conjugate axis of this hyperbola and conjugate axis is the transverse axis of this hyperbola. That is, so here it is this is the parabola. So this is the conjugate hyperbola. So this is conjugate hyperbola. Okay, conjugate hyperbola. So here if you see this, we call B and B dash as vertices. B and B dash as vertices. Already we discussed that. So this y-axis acts as the axis of the conjugate hyperbola. The curve which intersects the axis are called vertices of the hyperbola. Okay. So therefore here B and B dash are the transverse axis, and A and A dash is called conjugate axis. Now what is the equation of this conjugate hyperbola is x square by a square minus y square by b square is equal to minus 1. Understand? Now coming to the eccentricity E here, E square is E. So here the eccentricity is E is equal to root of a square plus b square by a square. Understand? Now for this eccentricity is E is equal to root of a square plus b square by b square. So this is a eccentricity for this conjugate hyperbola. See here the equations of hyperbola and conjugate hyperbola, they are differ by constant term. So here if it is a 1, here you will get a minus 1, and the eccentricities also we will get this here. Okay, now so between these two eccentricities we have a very nice result we have. So we use square, so here 1 by e square plus 1 by e dash square. What you will get, see here 1 by e square means a square by a square plus b square. 1 by e dash square is reverse it and square it. So b square by a square plus b square. Clearly it is equal to 1. Okay, now so this is the result we have regarding conjugate hyperbola. Okay, now what we are going to see, so for this all these hyperbola, so whether it is a original hyperbola or standard form of hyperbola or conjugate hyperbola, the center we are taking as 0, 0. Is it that for all the hyperbolas the center should be only 0, 0? No, not like that. For example, if you take any hyperbola, for example, it is a hyperbola, So here its center is not 0 comma 0, it is shifted somewhere some h comma k. This hyperbola is shifted, the center of the hyperbola is shifted to some h comma k. Then what will be the equation of the hyperbola and what are its vertices and the directrix, all those things we will see in the various forms of hyperbola. Okay, na? Welcome to this concept. So here we are going to see various forms of hyperbola. Now in the standard form, so we have seen the center is at origin, that is 0 comma 0, and this is the hyperbola whose transverse axis is x axis and whose conjugate axis is y axis. Okay, now whose conjugate axis is y axis. Now what I am going to do is, I am shifting the origin, that is center 0 comma 0 to another point C h comma k. I am shifting this origin 0 comma 0 to another point C h comma k, keeping the axis of the hyperbola is parallel to x axis and the conjugate transverse axis is parallel to x axis and the conjugate axis is parallel to y axis. I am not changing the what is called the orientation of the x axis and the y axis. Okay, conjugate transverse axis and conjugate axis. So the same thing, what we are going to do is, so we are shifted this hyperbola to another place. So that is center is shifted 0 comma 0 to h comma k. Now we have various so here different vertices we will get. Okay, so let us see what are those vertices and what are the equations of the lines, all those things we will see. The first thing is the equation of that transformed hyperbola is this. So that is wherever x is there, simply substitute x minus h whole square by a square. Wherever y is there, y minus k whole square by b square is equal to 1. So this you can get from the your 11th class or first year course of your CBSE. So in that transformation of axis is there. So there we will have that x is equal to x dash plus h, y is equal to y dash plus k. From x dash is equal to x minus h, y dash is equal to y minus k. So if you want to find out the transformed coordinates, that is x dash and y dash, so therefore in place of x dash you have to keep x minus h, in place of y dash you have to get y minus k, then you will get the transformed equation. So this is the transformed equation. Okay, now let us see what are the center, foci, endpoints of the from center to the directrix foot of the perpendiculars, all those things we have. Let us see. Here the very simple, don't by heart the thing. So for x, always remember, if vertices are there, coordinates are there. So then for x coordinate add h, for y coordinate add k. That's all. All forms will you will get that. So here the center will be add h and k here, h comma k, the center. The foci is, for this parabola, foci is plus or minus ae comma 0, just like ellipse. So all these are just like what are the ellipse is there, here also the same thing will be there. So x is equal to foci is h, here h and k, add h and k, that's all, h plus or minus ae comma k. So here vertices a dash is equal to hk, that is equal to h plus or minus a comma k. So b dash means what? End points of the conjugate axis, add h and k. So this is a h comma b dash, that is a end points of the conjugate axis. Okay, now b dash, that is equal to 0 comma plus or minus b, add h and k. So here also hk add, that is equal to h plus or minus a by e comma k, that means increment. For all the coordinates you are getting the increment, for x h increment, for y k increment. Okay, now coming to axis, equation of the axis. So here what is the equation of the axis here? X axis. So here what is the equation of the, so therefore what is the equation of x axis? Y is equal to 0. For this, what is the equation of the axis? Simply if the equation is there, right side you add h and k. For if it is y is there, add k. If x is there, add h. So this is equal to y is equal to k. equation of the directrix, x is equal to plus or minus a by e. Therefore, this implies x is equal to h plus or minus a by e. So, x is equal to h plus or minus a by e. So, if for y is there k, for x is there h. So, here also equation of the lattice rectum is equal to x is equal to plus or minus a. Lattice rectum is it is a focal chord passing through the focal fast which is perpendicular to the axis. So, for the equation of the for this transformed axis, we will get x is equal to h plus or minus a. So, equation of the conjugate axis here y axis, equation of y axis is x is equal to 0, for that x is equal to h. Understand? That is all. So, all the formulas are like this. So, in our some textbooks, then generally what they will do, no, they will bring this h plus or minus a by e to the left side, and they will write it as a x minus h plus or minus a by e is equal to 0, like that they will write. So, nothing wrong here, but you by heart these formulas like this only. So, you remember these formulas like this only, okay, right. I hope that you understand this concept. Let us go to next concept. Welcome to this concept. So, we are going to see the tangential conditions. So, whatever may be the conditions are we are going to see. So, if you observe the equations of ellipse and hyperbola, there is only one difference is there. So, what is the equation of ellipse? So, this is x square by a square plus y square by b square is equal to 1. What is the equation of the hyperbola? Equation of the hyperbola is x square by a square minus y square by b square is equal to 1. So, what is the difference between these two equations? The only thing is plus b square here you will get, plus b square here you will get minus b square. So, majority of the conditions, whatever may be the conditions or formulae. So, if you replace b square with minus b square, you will get the concepts of hyperbola. Just like now I am going to see. If there is an ellipse is there, the equation of the ellipse is x square by a square plus y square by b square is equal to 1. If there is a line y is equal to mx plus c, y is equal to mx plus c is a straight line which is to be the tangent to the ellipse x square by a square plus y square by b square is equal to 1. The condition of the tangents is c square is equal to a square m square plus b square. This is for ellipse. This is for ellipse. Already we derived. So, to get for hyperbola, simply wherever b square is there, substitute minus b square. That is all. So, here c square is a square m square minus b square. C square is equal to a square m square minus b square. So, this is the tangential condition. So, if it is an AB, hyperbola is there. If y is equal to mx plus c is to be a tangent to the hyperbola x square by a square minus y square by b square is equal to 1. The condition is c square is equal to a square m square minus b square. Okay, now, right. Just in place of plus b square, substitute minus b square. Right. Now what is the general form of equation of the tangent here? Y is equal to mx plus or minus. In place of c, we will write it as a root of a square m square minus b square. A square minus m square b square. But as you are a IIT student preparing for IIT examinations, you should learn each and everything perfectly. So, here y is equal to mx plus or minus root of a square m square minus b square. No. What is the condition on m? What is the condition on m? That you should be learn carefully. See here, a square m square minus b square is a quantity which is under square root. Therefore, we know that a square m square minus b square should be greater than or equal to 0. Should be greater than or equal to 0. So, from this we can write it as am plus b into am minus b greater than or equal to 0. Okay, now greater than or equal to 0. So, that means your m should be either greater than or equal to b by a, or m should be less than or equal to b by a. So whatever may be the slope of the line, the slope of the line y is equal to mx plus c, which you are going to see that should be either greater than or equal to ba or less than or equal to minus b by a. You know what is a and b. You know what is a and b. That means your m value, so this is a b by a and it is a minus b by a, should not lie between these values, b by a and minus b by a. Your m value should not lie between minus b by a and plus b by a. If it lies, then it cannot be the tangent for that line, hyperbola. Okay now? So I hope that you understand this concept. So let us see some more concepts. Welcome to this concept. So here we are going to see auxiliary circle and director circle of an hyperbola. Okay. So the definitions and concept are same as it is for the ellipse. Okay now. So once again I will explain this auxiliary circle. First let us see the auxiliary circle. The simple definition of auxiliary circle is, see here, this is an hyperbola, x square by a square plus y square by b square is equal to 1. X square by a square plus y square by b square is equal to, x square by a square minus y square by b square is equal to 1. This is the equation of the hyperbola. So here, so a and a dash is called the conjugate axis of the hyperbola. Okay now auxiliary circle is a circle whose diameter is conjugate axis of the hyperbola. That means, so if you draw a circle taking a dash as the diameter, if you draw a circle taking a and a dash as the diameter, then this circle is called auxiliary circle. The center is same. For the center is same for this auxiliary circle and hyperbola. Then what is the radius of this auxiliary circle? A. Why? Because the distance between a and a dash is 2a. Therefore, what is the equation of the auxiliary circle? So this is given by x square plus y square is equal to a square. X square plus y square is equal to a square. Right. So if you take the conjugate hyperbola, so for example, so this will be the conjugate hyperbola. So this is a conjugate hyperbola. So if you take this as the diameter, if you draw a circle taking this center C 0, 0 and it is a B, then the equation of this circle is a x square plus y square is equal to b square. So there are, for this original hyperbola and this circle, this auxiliary circle is for conjugate hyperbola. Here the transverse axis is BB dash. The circle whose center is 0, 0 and it is B. Therefore, x square plus y square is equal to b square. Okay now. So there are two equations of this auxiliary circle. But actual definition is what? So this is a very simple definition. But actual definition of the auxiliary circle is, let us see the definition of auxiliary circle definition. So here the auxiliary circle definition, another definition is, so let us take this foci S and this is S dash, foci of the hyperbola. Now what he is saying, take, so let us draw a tangent here. So I am drawing a tangent. So here tangent. Okay now, from S to the foot of the perpendicular. So from S, the foot of the perpendicular of the foci on the tangent. So let it be some point, any one point P1. Let it be P1. Okay now. Let us draw another tangent. Let us draw another tangent. So let it be foot of the perpendicular. Let us draw another tangent. From this is the foot of the perpendicular. Let us draw another tangent. Let it be foot of the perpendicular. So all these foot of the perpendiculars, all these foot of these perpendiculars, they will be on a circle. They will be on a circle. That circle is called auxiliary circle. So the locus of the foot of the perpendiculars from the foci to the tangents of the hyperbola is a circle called the auxiliary circle of the hyperbola. Okay now. So this is also definition of the auxiliary circle. Okay now. Now let us see what is director circle. Welcome back. So the equation of the director circle. First of all, what is a director circle? Let us see the director circle of the hyperbola. So this director circle is definition is same for ellipse, for and hyperbola, both are same. So what is a director circle? Let us see this. X-axis, this is x-axis and y-axis. Let us take the hyperbola in standard form. Let us take the hyperbola in standard form. The equation of this hyperbola in the standard form is x square by a square minus y square by b square is equal to 1. X square by a square minus y square by b square is equal to 1. Now how this director circle forms is, let us take the tangents, perpendicular tangents. Let us take the perpendicular tangents of this hyperbola. So what are the perpendicular tangents means? For example, you see here, this is a one tangent, this is another tangent perpendicular. So this is point of intersection. Let us take another two tangents which are perpendicular. The condition is which should be perpendicular to each other. Let us take these two tangents, and this is a tangent, these are perpendicular 90 degrees. Another set of tangent, this is also tangent, this is also tangent, this is a perpendicular. Another set of tangent and it is also tangent, this is a perpendicular. So if you see that the point of the locus of the point of intersection of the perpendicular tangents. So this, if you join all these points, this form a circle. This the locus of the point of intersection of the perpendicular tangents of an hyperbola forms a circle concentric with the center of the hyperbola. Okay now. So the equation of this director circle is x square plus y square is equal to a square minus b square. Understand this? X square plus y square is equal to a square minus b square. Here the radius of the director circle is root of a square minus b square. X square plus y square is equal to r square. R square is equal to a square minus b square. Therefore, r is equal to root of a square minus b square. Okay now. So from this we can say here a square minus b square should be a positive quantity. A square minus b square should be greater than or equal to 0. Okay now. So this is a locus of the point of intersection of the perpendicular tangents of an hyperbola is called the director circle and concentric with the hyperbola. The equation of the director circle is x square plus y square is equal to a square minus b square, and whose center is 0, 0 and radius is root of a square plus b square. Okay now. Right, I hope that you understand this about this auxiliary circle and director circle. Okay now. So let us move to next concept. Dear students, let us see one problem here. So very small problem. So equations of the auxiliary circle and director circle of the hyperbola whose equation is 9x square minus 16y square plus 72x minus 32y minus 16 is equal to 0. So whenever such type of equations is given, so immediately remember that for this hyperbola center is not 0, 0. Okay now, it is not center 0, 0. This is something, the center is shifted to something from h, k. From 0, 0 to it is shifted to h, k. So for that what is the equation of that? So x minus h whole square by a square minus y minus k whole square by b square is equal to 1. Now you have to convert the given equation, that second degree equation, into this form, so that we have to identify the values of h, k, a and b. Then we will find out the equation of the director circle and equation of the auxiliary circle. So let us do that. Now for that what you have to do is, first write the x terms one side, at one place. X square plus 72x as a one bracket minus 16y square minus 32y square. So minus of 16y square plus 32y. Take the constants to right hand side plus 16. Okay, now, so this you can take 9 common outside, x square plus 9, so 9 8s are 72x minus 16 you can common, y square plus 2y is equal to 16. Okay, right. So this you have to express as a perfect square, x minus h whole square or x plus h whole square, no problem. So this is a 9 into, this is a x plus 4 whole square minus 16. This is 16 into, this is a y plus 1 whole square minus 2 is equal to 16 minus 1. So this is a y square plus 2y plus 1 minus 1 will get cancelled. This is x square plus 8x plus 16. 16 minus 16 will get cancelled. So now you multiply inside. So this is equal to 9 times x plus 4 whole square. 9 16s are 144. So this is a minus 16 into y plus 1 whole square. This is equal to plus 16. This is plus 16 minus 16 will get cancelled. Take minus 144 to that side and divide with 9 16s are 144. So you can write it as x plus 4 whole square by 16 minus y plus 1 whole square by 9 is equal to 1. Okay, now, so is equal to 1. So here what are the values of h comma k? H comma k is minus 4 comma minus 1. So your a square value is equal to 16, b square value is 9, a is 4, b is 3. So as now coming to the first one. Now auxiliary circle. Auxiliary circle. What is the equation of the auxiliary circle? So if you see here, a is greater than b, a square is greater than b square. So therefore, what is the equation of the auxiliary circle? Generally x square plus y square is equal to a square. But here it is not the hyperbola of the standard form. Now here you have to take this as a x minus h whole square and y minus k whole square is equal to a square. Okay, now. Okay, now so this is equal to x minus h value is minus 4, y value, sorry, h value is minus 4, k value is minus 1. That is h plus 4 whole square plus y plus 1 whole square is equal to a square is equal to 16. Therefore, this is the equation of the auxiliary circle. Okay. So, wherever x is there, substitute x minus h, wherever y is there, substitute y minus k. Next one is director circle. So, what is the equation of the director circle? X square plus y square is equal to a square minus b square. Now, here what is the equation of the director circle for this? So, this is a x minus h whole square plus y minus k whole square is equal to a square minus b square. Now, substitute h value and k value. A square is equal to 16, b square is equal to 9. 16 minus 9, 7. Therefore, so your answer is x plus 4 whole square plus y plus 1 whole square is equal to, this is 7. 16 minus 9 is equal to 7. So, that means here from this problem what you have to observe is, if it is our auxiliary circle, in place of simply put in place of x, x minus h, in place of y, substitute y minus k. Okay, now, right? I hope that you understand this solution. Okay. So, dear students, I hope that you enjoyed today's class with some more concept, very important concept. So, tomorrow's class I will stand before you. So, until then, all the best.